Robinson, who's the CEO of Evoco. Welcome back, Jason.
Thank you very much. And
All right.
So I guess we'll start the panel, and I'd like to introduce Alex Goshevsky from Algonet, Luke Haveralls from Natural Fiber Welding, and Tom Claypool from Native Brand Shoes. If you guys can turn your camera and microphones on now. Hello.
Hey, everybody.
Hi there.
Hi. So I think we'll start by, I'll do a brief introduction myself, but I kind of wanted to make this this panel organic. So we're going to obviously deep dive into everybody's technology and expertise here. But if there's a question that does come up during the session, and it's really, you know, it makes sense to engage it there, I may pick up your question instead of leaving it till the end. And I think that might help make the conversation a little bit more organic and working with the people we're watching. So I am Jason Robinson. I'm the CEO founder of Evoco Limited. We're a Toronto-based company. We focus on plant-based chemistry that could be made into materials and products. We are now fully focused on the footwear industry for various reasons, but mostly because I think it's the right time to for brands and technologies like ours to be adopted across a wide scale of different applications. Plant-based chemistry is foundational to us. So we look at plants, derivatives of plants, and tailor that chemistry towards not only high bio content or plant-based content, but also towards performant and specific products. So today in the footwear industry, we're working on insoles, midsoles, and outsole technology, and have a pretty broad base of consumers around, or customers around the world, reaching various consumers. So I'd like to ask a little bit for Alex to kind of start us off here and to go a little bit more into you know, what you're doing at Algonet and the interesting stuff there, and give you a little bit of time to talk about that, and then we'll move to Luke and then eventually Tom. So thanks very much.
Sure. Yeah, thank you. I'll keep it brief. So my name is Alex. I'm the co-founder and COO at Algonet. And basically what we're doing there is taking seaweed and turning it into yarns. And we're specifically focusing on producing yarns and fibers at this point, as we find it to be really the foundation for a lot of textiles and materials that we use every day. And at the same time, we really want to create a solution that can work with existing yarn and fiber manufacturing systems to make it really easy to adopt and scale into the future. But with that, we were founded in 2017. So we're on our 4th year, and we are based in Brooklyn, New York.
Thank you, Alex. Luke, you want to go ahead?
Sure. So I'm Luke. I'm the founder CEO of Natural Fiber Welding. My technical background is PhD in chemistry, material science. Natural fiber welding is, I'll stay with the plant and using, growing things theme here. We use materials that are abundant in the world, that are natural. And then our approach is that, so when I was a professor at the United States Naval Academy, I had this hypothesis that if you could make natural materials moldable and shapeable in ways that are akin to how plastics are moldable and shapeable, then that would be revolutionary. And so I started focusing on really a combination of chemistry plus manufacturing techniques to be able to take materials that you find in the natural world, waste cotton, sawdust, vegetable oils, etc., and then be able to mix and mold and shape those materials directly without breaking them down to make things like, leather-like materials, foams, etc., that are 100% natural, 100% recyclable, and that literally take the lowest cost commodity materials that nature and agriculture can produce to do that. So we're doing that now with focus also kind of on footwear and also things like T-shirts and polo shirts that Ralph Lauren, for example, is taking to market. And anyway, a broad platform that makes many different kinds of materials possible and lets people design products in a different way.
Thank you, Luke, and very insightful stuff there. Tom, Native, how are you doing, Tom?
Great, thanks. So my name's Tom Claypool. I'm one of the co-founders of Native Shoes, a brand we started in around 2008, 2009. You know, I want to do another thing, actually. I appreciate the land acknowledgement that was given earlier. And I would also like to acknowledge that Native Shoes is founded and headquartered on the unceded territories of the Musqueam, Squamish, and Tsleil-Waututh nations. I'd like to thank them for having cared for the land that we live and work on and play on, and recognize our responsibility to advocate and be allies for ongoing Indigenous reconciliation. That's important to me, and I just wanted to mention it. I personally live in Furry Creek, which is in traditional Squamish and Coast Salish territory, and the land that I live on was a traditional and sacred bathing ground for the Squamish people. So yeah, that's a little bit about where I live now. We're in Vancouver, British Columbia. So Native Shoes as a brand, you know, we're a purpose-led brand encouraging all to live lightly. I mean, that's a broad kind of statement for a lot of things that we're about, whether it's the physical weight of our footwear, the lightness to which we like to bring light to the world, also the way that we approach things without taking ourselves too seriously, but also being, you know, really serious about the work that we're doing. And so, you know, from the beginning, Native Shoes has always had an environmental thought about the brand in terms of, you know, when we got into footwear manufacturing, we looked at different traditional methods of footwear manufacturing and materials that were used, and you know, when we started to learn more about all of the waste produced from offcut and all the energy and water used in all the traditional materials, we ended up you know, getting into injection molded footwear, which is essentially three components of finished materials that are assembled together. And they're all polymer based. And that's been our challenge in terms of being a responsible manufacturer, is getting, you know, learning more about the biomaterials realm related to biopolymers. Also in speaking with Jason and learning more about biopolymers that have the ability to degrade naturally back into base elements and not become microplastics. You know, we're really into our Native Shoes Remix project, which is our take back program. We offer a recycling program for our footwear. And we're able to take back the injection molded shoes, grind them, and repurpose them, give them a second life. And it's a fully built out. It's out of a pilot stage. It's a built out program across North America. We're working on expansion into Europe. And you know, we've also gone into different endeavors and learned a lot about what it means to be using strictly plant-based materials. We came out with a plant shoe a few years ago that had no polymers in it. And even so far as when working with Pinatex, they had some polyurethane in it, traditional polyurethane in the material that they're making out of pineapple husk, and we actually had them remove that. You know, we didn't use like a nylon thread. We used a olive oil lubricated jute, and so it was really cool and really interesting to get into that realm of, and that's more traditional assembled footwear. But there was some quite a bit of organic cotton in the upper, and we started to learn also more about what our impact would be as we did an actual product LCA, a screening LCA on that shoe. We were kind of surprised at what a high footprint it had, and it was primarily related to the water usage that was like to grow the cotton, you know, and so maybe when we revisit that, we'll get into more less water intensive materials, or hopefully, I mean, Alex and I have been speaking for years. We'd love to use her algae based material to knit some uppers for our shoes. I think that's a fantastic opportunity as the technology continues to scale and develop. But yeah, so surprisingly, our regular injection molded shoes, which are essentially plastic foam with some thermoplastic rubber and urethane as decoration for the rubber rand and the license plate, that had a really low carbon footprint relatively, because there's so much less involved that goes into the material and the processing of the materials. And so a lot of learnings along the way. But I think if I had kind of a long-term end goal, it would be that all of our product can be fully recyclable. I mean, we've set some KPIs and we're working on some science-based targets for our brand in terms of carbon neutrality or even a step beyond that. But really, I'd like our material to get to a point where we're not having to upcycle or downcycle our product when it gets to the end of its useful life, that we have the ability to truly recycle our material and bring it back into its original form and use it again for a new pair of shoes. Alternately, something which we achieved in our plant shoes, something that's commercially, where accepted, commercially compostable and also compostable in the backyard over, the outsole being the longest one to degrade, but essentially composting. And that's kind of like where we'd like, if where we're at now is we're using traditional materials, moving into more biomaterials, but still all biopolymers that are not fully circular. So they need to be upcycled or downcycled. And where we'd like to go, hopefully with members of this panel, are to a point where we're fully circular and all of our shoes are either fully recyclable or fully compostable.
Yeah, and I think we can kind of go back to circularity, and there's various discussions on how that, the challenges with that and what does circularity mean? Is it a natural cycle? Is it an upcycle? And I think Luke does have some interesting comments on that. I did see your website, so we'll kind of unpack that in a bit. But I think one of the things that is interesting from this panel's perspective is that overall, there's this goal to innovate around sustainability, carbon reduction, trying to reduce carbon and the carbon impact on climate change and the environment, but also secondary, tertiary things like circularity, recycling, biodegradability, but performance is kind of that key requirement. I'll start off with a comment really around the impact of fashion and footwear on the global carbon balance, and there's an article out of FT that mentioned fashion and footwear accounts for 10% of global emissions, of which 40% of those emissions attribute to materials alone. So any type of carbon reduction relative to that is going to be critical. And I think both Alex and Luke have technology that does that. So let's unwrap your technology a little bit more and understand this nature of that sustainability. So Alex, why don't you talk around that first and how you're reducing carbon and how you've quantified that and a little bit more around that circularity of it.
Yeah, absolutely. I mean, I think all in all, just to kind of go back to something Tom was saying, we're all learning and we're all trying to take the next best step, and our products might not be perfect right off the bat, but we're definitely all trying to get there and we're all trying to accomplish the same goals. And for us, we're really trying to produce a thoughtful product, and we're taking into consideration everything from start to finish. So really looking at all the inputs and also trying to understand all the impacts at the end. And right now, what we're doing is really collecting as much data as we can in all of those sectors, from, the raw materials to production to end of life. But, for us, the core of our product is seaweed, and it's a major component of what we're producing. And, you know, when it comes to CO2 emissions, seaweed on its own has all these really incredible metrics around capturing carbon and sequestering it. And there are so many other benefits that come along with seaweed. The fact that it's grown all around the world, the fact that it doesn't require land to be grown, and it takes advantage of, you know, the water that takes up 70% of our planet, although it's not all of it. You know, it's an area of our world that has so much potential, unexplored potential. You know, and the other thing is, because there is no plastic in our material, there is no shedding of microplastics, which, you know, we're all aware of. There's traces of it in everything from these single-celled organisms to us. And so we're really happy to be, you know, on that journey of reducing microplastic pollution as well.
And it's just a quick follow-up question. I mean, this idea about, you know, seaweed absorbing carbon, being a carbon sink, I mean, that also helps reduce your carbon footprint. Can you kind of explain to the audience what a carbon sink is and how plants do actually absorb this carbon?
Yeah, I'm not a scientist. Maybe Luke can speak a little better to this than I can. But in terms of seaweed, you know, it absorbs the carbon in the water and it keeps it in its root system. It doesn't technically have roots, but something that functions similarly to them. Then it's, you know, kept in the ground, and we're not releasing it into the atmosphere.
Right, right. And so kind of pivoting over to Luke, I mean, you got a couple of products, you know, Claris, Mirum. Can you explain a little bit more about what's in both of those products? You know, the Mirum product being 100% plant-based certified. We'll get into certification in a second, but talk a little bit about those two products, because I think that they're very interesting.
Yeah, thank you. So it goes back to molding and shaping. I'll actually, the simpler story, I'll talk to Claris first. I'll come back to Mirum. So cotton, we can note that cotton's not a perfect crop. I'll also note that some people's data, sometimes on the water use, people consider how you calculate rainwater versus what's irrigated is a thing to consider. And then I'll say, even better than using virgin cotton is if you could recycle it. There's about 55 billion pounds of cotton, for example, that grows in the world each year. About 48 billion of those pounds actually gets converted into textiles. The rest is fiber that's too short that goes into non-wovens and paper and things like that. And then there's hundreds of billions of pounds of cotton sitting in our closets in the form of old t-shirts. And the reason why that cotton doesn't get recycled is a combination of logistics and unit economics. And one of the key problems is the fiber is too short when you go to, especially when you go to mechanically recycle it, which is one of the less expensive ways of doing it. So here's a yarn, card of yarn. You can see that it's a cotton card of yarn. I don't know if viewers can see this, but it's kind of hairy and fuzzy. And anyway, when you make cotton into a yarn and you use short fiber, you get yarn that's weak. You get yarn that pills when it gets turned into fabric. It doesn't do the things that nylon or, you know, that synthetics can do, which is you can mold synthetics into filaments, for example, and they wick moisture differently, et cetera. So here's the same yarn, but after a fiber welding, molding, and shaping process. And what that yarn can now do is it can wick moisture as quickly as a Nike Dry Fit. It can breathe better than a synthetic. It's cellulose. So the beautiful thing that Alex is bringing up about algae is, you know, cellulose is the most ubiquitous biopolymer on planet Earth, many gigatons per year of it produced. And so it's basically a sugar at its base level. And all of us have been optimized through time to prefer cellulose against your skin as opposed to synthetics. And so that's another thing is if you could package all of the utility that you get out of a synthetic, but use the natural material, well, then you get the best of all worlds. So this Claris is based on this idea that you can mold and shape fiber and yarns and fabrics to get the kinds of morphologies that are normally delivered with plastics. So then we can generalize that. We can say, you know, by the way, and that technology applies to not just cotton, but the reason why people don't grow industrial hemp in this world and cottonize it has to do with the price to performance ratio of the fiber that you get from a hemp crop isn't as long for the price that you pay to get it as you do with cotton crops. So even though, you know, hemp's been legal to grow in China for decades, people tend to grow cotton there. Okay, but this technology I'm talking about solves that. But let's generalize it. So if you could just take materials as they are, as nature produces them, there's cellulose, there's lignocellulose, there's elastomers like latex and natural rubber that isn't just come from the sap of trees, but can come from dandelions. There's all sorts of vegetable oils of various sorts. If you could put those materials together as nature produces them without having to break them down, then there's a whole new realm of composite making that one can do. And by the way, what I'm talking about isn't biofabrication. We're not talking about biotech. All of the most important materials that humankind needs to make these products already exist. They don't need to be genetically modified. And in fact, when you grow something with a single platform, you're very limited by it. So, you know, there's only so much a mushroom can do, because a mushroom can only be a mushroom, can't be anything else. So here's Mirum. Mirum is a complex composite. It takes, there's actually multiple kinds of materials that are put together here to make it. Then, you know, in the case of a leather-like material, you might want to crumple it up or have it Bailey flex hundreds of thousands or millions of times. You need it to do various things. And so that composite structure is what needs to be created to get the performance. And so that's what we do. We look at the world and we don't see just a single plant or just a single kind of input. We see commodity already existing waste streams in the world. And if you can take those materials, mold them and shape them and turn them into everything from leather-like materials. So here's a foam that is 100% natural, right? Here's the world's first recyclable shoe sole. So unlike rubber today, people don't recognize that, you know, materials like leather aren't really natural when you buy, well, they're natural. They start natural. They start as a hide, but then they're subjected to the tanning process that turns them into something else. Most people maybe don't know that when Goodyear got famous for vulcanization of rubber, rubber is vulcanized through sulfur and petrochemicals, or today peroxide and petrochemicals. And when you have a rubber shoe or a tire, and at the end of its life, you grind it up, you can only grind it up into dust. And so you can make football fields or asphalt or things. Anyway, what I showed you earlier, this literally can be turned into a remoldable, reshapeable material that can go right back to another shape, another kind of a shoe sole, and not through a chemical process either. So anyway, so there's patented technologies we have developed, and now that we're scaling up in the world, that let people again think about their, you know, to Tom's point earlier, when you run a business model and you're going to do a circular take back program, then it's super important that you don't bankrupt yourself. So you want to be able to run that product through a model that actually makes sense for everybody in the supply chain and yourself, such that more people can enjoy the product. And then you can sell it to enough people that you have the effect. So all of these solutions I'm talking about are optimized around price to performance ratio, so that not only the very fortunate amongst us right now, there's you know, 1 in 4 people on planet Earth right now gets to enjoy the materials made from, you know, petrochemicals and the ways we make things today. There's 3 out of 4 people on planet Earth that don't get to enjoy houses full of clothes and, you know, closets full of footwear, et cetera. And you think about the impact of just the quarter of us of our consumption. Then you think about, what if everyone was going to live like your average American? Okay, we got a big problem to solve in this world. The beauty is, more new plant matter will grow today on Earth than the combined tonnage of all the synthetic things made by people in a decade. One day of abundance. So seaweed, and the list goes on of those kinds of materials that are abundant. So when people innovate ways to use those materials more directly and more efficiently and in circular ways, then you get to use the circle of life. And that's the most powerful technology that we never had to invent. It was all around us all along since people have become conscious.
Yeah, and I think you raised a couple of good points there. It kind of segues into kind of where we wanted to go with the conversation, which is, you know, how are we educating the public in terms of allowing them to understand what, you know, plants have this huge regional diversification, and also diversify itself within the nature of the plant to be a whole bunch of different things. there's the education part, but there's also, how do we quantify what we're doing, right? How do you, in LCA, you brought that up, and how do you create boundary conditions on your LCA? I mean, you can often, and leather is a touchy subject, but people will often say, growing the cow is a part of that leather LCA when it's actually a byproduct, and we have to kind of consider that, depend on your socio, ethical standpoint, that's where you set your boundaries. But the reality is leather is a byproduct, and we won't go into that conversation at the moment. How about that? But what I will say is that, we need to kind of coach the general public, the consumers, and work with brands to help do that. And certification is one of them. And I just wanted to kind of ask Tom a little bit about certification, and go back to Alex and Luke and talk about LCA and what an LCA is and what's that mean. So Tom, what do you use for certification? What are you interested in terms of certification, and how do you communicate that to the general public?
Sorry, I said to unmute myself. So LCA is a life cycle analysis, and we are using that initially. We did we're working with a third party named Qantas, who's pretty well known in that realm of life cycle analyses and different carbon footprinting. So we realized rather quickly as a brand that in order to make improvements, we were going to have to kind of get an idea of where we are, to kind of like benchmark ourselves, to understand, what the impact of our product is as it is currently, so we can start to make improvements on that moving forward. Because we're working with a third, a party, like a third party on this, or an outsourced company, Qantas, they actually, I don't have all of the nitty gritty details of how the calculations are done and those types of things per se. I'm more involved in kind of like making sure, like getting, like, there's a lot of very detailed information that needs to be collected from the manufacturers, and a lot of times, it would require lengthy conversations with the owner of our manufacturing partners, and convincing them to release what they would consider, kind of confidential data about their business that they might not want to share. So that was more my role in the LCA process. But so we did an initial corporate carbon footprint analysis. I believe it was a level 3. There's like a stage 1, 2, and 3, and we did a level 3 because we don't own our own factories. So it was less about our single office, and we don't have a big retail network of our own self-owned retail stores. We just have a few, and we have one headquarter office, and that's really it for our own. We're not like a company, like a Tesla that has like all these manufacturing locations that they own themselves throughout the world, right? Or at least throughout America and China, and as they're proceeding into Europe. But so for us, that was the type of corporate footprint that we did, and that was completed last year, and that's what we got a lot of learnings about our product, and we're able to start to understand where we were, some of the positive attributes and some of the negative attributes to our product, and start to set a roadmap of where we wanted to go. So now we're in a second phase with Qantas again, and then also have a sustainability consultant that has come on to help us, Allison Murphy. And she is helping lead the work around some of the work that we're doing for our science-based target setting. the greenhouse gas emission reduction, and that's or at least the data gathering, and then plans for reduction. And what was very interesting, just to give everyone an idea about where things pop up that you might not necessarily think about are going to be your biggest contributing factors. One of the things for us that was kind of an aha moment, which are always interesting when they come up, was our energy consumption. That's one of the largest contributors to our greenhouse gas emissions. And it's not from moving products across the Pacific Ocean, the sea or the ground transport to get products, to our different distributors and through our different distribution networks. It's the amount of energy that the injection machines use, how hot they have to run 24 hours a day, essentially, which is most factories run a 23 8-hour shifts, or 2 12s, depending on where you're at, and that those machines run so hot all the time. It's actually, that we are consuming more energy than anything else, and that being a large factor in our greenhouse gas contribution. And so, what we've done recently is to work with our manufacturers and look at, really start to plan getting solar panels on the roofs of every factory building that exists on their property, you know what I mean? And also sourcing energy from green renewable sources that aren't part of the standard grid, but are available in the countries where we manufacture. So those are some of the things that have come out of the LCA, and I mentioned the plant shoe as well, and we're not shying away from that. I think it's just the realization that we can look at other materials and our design process, which is something that is also super critical when you're looking at a product design perspective of are you designing the product to be in a circular fashion? Can it go cradle to cradle? If it goes cradle to grave, how does that look like? What are the components you're using? What are the materials? All those kinds of things. So, yeah, that's a little bit about what my experience is with product lifecycle analysis and the work that we've done so far. I would encourage everyone to do it. I mean, I think Allbirds just released publicly an LCA and the tools that you can do to do it yourself, because it's not inexpensive to work with a third party. If we were still scrappy like we were in 2011, we probably would be doing it on our own and just using the tools that they provided. At this point, we've grown to the size where we can, and we also, so it's not just that, but it's also the third party. And I think you got into certification, or you mentioned certifications. I don't know if there's a specific desire for certification to come out of this necessarily. I think that we are, so I can't speak to certification a little bit. So for example, the work that we're doing right now on the product LCA that we're working on in moving from traditional EVA foam to a more bio-based EVA foam, we are doing an ISO level product lifecycle analysis that will allow us to, once the LCA is completed, it goes through a third-party review outside of Qantas, outside of our organization, by industry professionals that do the ISO certification. And then we can start, if we decide to message outwards. Right now, we're only doing this data collection for our internal purposes.
Sorry. So when we think about this, I mean, obviously a life cycle analysis looks at cradle to cradle or cradle to grave, factory gate. You can set certain boundaries, but kind of talking about this relative to your materials, Alex, I mean, you guys must have done that, coming from Seaweed, it's got a regenerative process, it's a carbon sink. Your LCA must be also pretty solid around kind of looking at that relevant to say polyester, which has probably got the worst carbon footprint no matter if you include rainwater or not in cotton, right? So I think, maybe talk a little bit about what you've guys done there in terms of looking at your process and your raw material as a carbon reduction technology.
Yeah, absolutely. And there's a give and take to everything. And this is kind of a separate conversation, but with these new materials, we're never going to be like polyesters. There's always going to be, each material is different from the other. So in terms of performance, which we can come back to, we're all going to have our own differentiators. But in terms of LCA, as Tom said, we are early in our development still. And we ran a preliminary internal LCA just to get an idea of where we stand and what areas we can further improve and focus on. And we are in the midst of doing our second round with an external firm, which is really exciting so that we can, validate and further firm up some of those numbers. So all in all, we're still learning. But like I said, we've been really thoughtful with all the inputs, and it would be wonderful if, we can have localized manufacturing to where the seaweed is actually being grown and harvested, and, have a recycling program right there and then. And, those are all ideal situations that are going to take time to get to. What we have been focusing on in the meantime, though, is just collecting data on, our material and aligning with ASTM standards, which are used for textiles around the world. And we've also been doing things like degradability testing and understanding where we fall, which is a huge component of what we're doing, making sure that what we take from the earth, we can essentially give back, and understanding, the terms that our products last when, or the terms that the material lasts when it's put into the products, and all these wear tests and things like that is what we're hoping to get more information on.
So using kind of standards, ISO, ASTM standards, you can benchmark your product performance against others, which is a great tool to go out and say, well, if, for a piece of clothing or for an upper on a shoe, you can actually benchmark your performance against theirs, and then obviously learn how to improve it through innovation. And I think
exactly. And when it comes to brands and other partners, they are also looking for a baseline, and they're also looking for some type of understanding. And if we can speak the same language, which for us has been, using ASTM standards, it gives people an idea of where things fall. And it doesn't seem so arbitrary and scary.
Yes. And Luke, I guess, I went to your website, USDA biopreferred 100% on Mirum, which is a great feat. We have stuff that's 70 to 80% and obviously moving towards 100. But talk about that type of certification. It's almost like the equivalent of USDA organic on your apples and oranges. And so now you got this organic rating on your product. Can you talk a little bit about what's entailed in that, and then maybe other certifications you might look at?
Yeah, the measurement is isotopic carbon. So carbon that's been in life has a particular sort of fingerprint to the type of carbon nuclei that are in the atoms. And if your carbon has come from a long dead prehistoric thing buried deep in the ground, it has a different fingerprint. And so if you want to know if any material comes from carbon that's been alive versus carbon that's been long dead and fossil, then there's some standard tests in the world to do that. So it's as simple as that. It brings up a really important point, though. There's, so let's start with saying, when you run a business, accounting methods are really important, accounting processes. And we all know that depending on what business you run, dollars that flow through your marketing part of your business versus dollars that flow through your, shipping department, they're all dollars, but they have a different effect on your business. They have a different effect on the macro. Okay. An LCA is something like accounting principles. It's a structure, it's a framework, and it's appropriate not to necessarily just, you can get numbers out of LCAs, but really what an LCA is best used for is a structured discussion. But then there's something else that's really important too, which is if you don't have the right data going into that structured discussion, you end up with the wrong answers. And so, okay, when we did the biocertification, what we wanted to prove was that the carbon is 100% coming from life, not from fossil something or other. And so, you know, there's a standard, in that case, there's a standard accreditation process that already exists that anyone can use, can put your materials into and find out. Okay, and that's all well and good, but then we can talk about, and there's other kinds of data in this world. I'll just say, as important as LCAs are, what's even more important, and if you see my stuff on LinkedIn, what you'll see is, so I came from an academic background, and in the academic world, peer review is very, very important. And when Tom brings up third-party review, he's talking about peer review. It's really important. There's a thing in this world that's missing. And I'll say it's not germane necessarily to NFW's business model and what we do, but I have a personal hobby, which is I believe that the world needs an open source, peer-reviewed set of standards of data that goes into LCAs. You can do the best LCA work, spend all your time setting up your framework just right. And then when the petrochemical industry forgets to tell everybody that, oh, by the way, for the last couple of years, and you can Google this right now, for the last couple of years, there's been satellites flying around planet Earth, looking down at planet Earth with standoff spectroscopy and the ability to look at methane emissions. And there's been an underestimation in both the production and delivery systems of producing fossil fuels by between 50 and 90% is the current information.
Yeah.
Okay. Higg index, et cetera, doesn't use that data.
No, you're right.
So okay, if that means if we're putting in, you know, like Tom needs to make decisions about things like what materials he wants to use. But when the carbon footprint of everything that's plastic in this world is underestimated by at least a factor of 2, well, anyway, like if he knew that, he'd make a different decision on how he's running his business. And so that's a really important point. I think, like, we need primary data that is tied to where things come from and how they're produced. It needs to be open source and peer reviewed. If you have to pay for it, then you have all these problems with interested parties wanting to massage the inputs, which doesn't get you the kind of auditing process that's fair and impartial, that drives people towards defining the right problems and therefore coming up with the right technical and business solutions.
Yeah, and I agree with that, because I mean, you know, you can use the CREET model or Higgs index and whatever you want to use, and then the reality is some of that database is old. And I mean, we were looking at, for example, an EVA product, and it was outdated because I saw published data, which was from another party, showing that it was actually 3 or 4 times higher. And so the problem is that, you know, all this is very specific to the product you're talking about and to the industry you're talking about. And there's a lot of invested interest relevant to this as well, right?
That's right. It gets even more complex when you start doing relative sort of comparison. So I saw an article the other day where someone was talking about their bag, and they said that the claim was the bag, which, let's say this bag at most weighed a couple of pounds. So let's say the bag at most weighed a kilogram. They said that the bag was responsible for over 16 kilograms of carbon sequestration. Okay, it's a 1 kilogram bag. I can tell you, anyway, we can do stoichiometry is the study of chemistry and how moles of atoms or ratios of weights and things are taken care of. But I can tell you that there's no way that a bag like that has physical ability to be sequestering 16 times its own mass worth of carbon dioxide. Okay, so what was clear there was it was a relative calculation. So it's like, I don't know, it's called the study is called the logic is called counterfactual. So here's 2 scenarios for you, Jason. You can either buy a bag and maybe pay some amount extra, and they'll plant a tree, and then they'll calculate the LCA of what that amount of like carbon is. Or your other choice is you get to start a dumpster fire.
Yeah.
Okay, and now what we're going to do is we're going to look at the delta between Jason running around starting dumpster fires versus buying this bag and letting them plant a tree, and now you get a delta of 16 kilograms of carbon. You know, okay, anyway, I don't know where that number came from. I'm making up a scenario, of course, but
Yeah, and I think
illustrate a
what
point.
you're trying to get at is that, people can, manipulate the data in best interest of themselves. I mean, we do an LCA across a variety of different of our materials. The LCA is, at the material. It's like saying our materials are less carbon. We can affect that, right? Manufacturing processes, whether they're similar or different, we can't affect that because that's out of our scope of work. But we can, if you use our material, which again takes up 40% of fashion footwear emissions, so 4% of total emissions, if you use our material, you will get a fundamental decrease. And yes, if you use updated information about fossil fuels, it will be even more. So ours are very conservative, and it's not really a justification of what we're trying to do.
Yeah, by the way, when I was using your name, Jason, I was only, of course, trying to create a hypothetical situation, not in any way implicating that you were a part of the problem.
No, and I think, we do use third parties and stuff like that. One other thing I'd like to mention is just, on the certification side, is really around this idea that certifying with third parties is quite important to help educate the consumer. We use USDA BioPreferred because you do that C14 analysis. It's telling you it's plant-based or new carbon. We also use a company called Green Circle Certified. They go through our whole supply chain. So it actually proves the plants you're actually using or the raw materials that are plant-based are in the materials, and that you're selling the product you're selling to, because not everybody wants to buy a pair of shoes and do a $300 analysis to prove it's actually plant-based, right? So I think from that perspective, we have to work as companies to help educate what we're trying to do and why we're trying to do it. LCA is one method, although very complicated. And yes, we have lots of things to work on relative to that, but also other certification actually prove it's plant. And I think if you're starting with the plant-based product, you're already better than using petrochemical. So I've been prompted to ask some questions now from the audience. We kind of blew through that pretty quickly. So I'll start from the top and try to work my way down. What's the maximum amount of seaweed you can use? And would you rather, and would the other part of this be cellulosic? So I guess, are you using oil or the cellulose or the fiber part of the seaweed? What's your play there?
Yeah, so for us, we're not using the whole crop. We're only using selected polymers that are found within the crop that are processed, right? And then we're not using cellulose that can be used in other areas. I think in general, the seaweed industry, seaweed is used in food and beauty and other industries. So there are a lot of applications for it. And even though we're not using the whole crop, there are other areas that the polymers we don't use can go to.
And I had another question for you. I guess, what brands are you working with, and is your product commercial? There's a couple of them that were kind of similar in that respect.
Yeah, that's a great thing to address. So we are not on the market right now. We are working with, we've spoken to all sorts of brands, from small independent designers to larger, worldwide brands. And it's important for us to connect to all these different brands to understand what their challenges are, what their needs are, how we can integrate with them. For us, it's really important to make this an accessible material in the long run. So being able to have these conversations is extremely valuable for us.
Perfect. There's a question regarding Mirum. What's the durability of Mirum? Does it perform like leather? And also, is Mirum from an organic feedstock? So obviously it's plant, organic, I guess it's pending the definition of what organic is, but it is from plants. So I guess, how do you process is one question to make it into a leather, and then talk about performance of that. Kind of a quick 1 minute jobby on that one, if you can.
The quick analogy to let you know how Mirum is made is, think about what goes on inside a kitchen. So every kitchen has mixers. Every kitchen might have like rolling pins. It has an oven, maybe a panini press. Then there's spoons and knives and forks and things to, mix and do different things to the material. So NFW, again, this molding and shaping approach is that we're sort of a big industrial kitchen, if you will. We use particular elements. When you're cooking, of course, you're doing chemistry. So how you brown your onions and caramelize your onions might give a particular flavor or aroma to your dish, depending on, and not every dish has it. So mirum is a complex composite. So generally speaking, it has vegetable oil, citric acid. It has lignocellulosic fillers, fibers, etc. And we actually pick the recipe just like a good chef can make souffle or birthday cake or bread or crackers. Same basic ingredients. Maybe there's different spices here and there, but you get those very different properties and outputs. We do the same. Moreover, when you make a sandwich, you have choices. There's different breads, there's different kinds of cheeses and meats maybe that you put in the middle. Again, we can make multiple kinds of mirum formulations and then bond them together and make a complex assembly. So, okay, when we go to then, does it perform like leather? The truth is, well, first of all, let's be really clear about leather. Leather means many different things in different contexts. So, there's leather that is like the Strobel board on a shoe that's like very stiff and wooden almost. And then there's the supple leather, that you make an upper out of or something like that. So like a material like this, for a casual shoe, you need to do at least 100,000, maybe better, you should do 200,000 Bailey flexes. If you want to be like a work boot or on the trail, you need 500,000 Bailey flexes. So anyway, we can tune mirum to be able to do hundreds of thousands and even millions of Bailey flexes. So does it perform like leather? Well, when you need it to flex, yes, we can make it flex.
Yeah.
And then we could go into, there's other properties and aesthetics. And I'll just say some people really like that we can make mirum look a lot like leather. Some people prefer that we make something brand new. It's a chance to make a material that literally has its own new aesthetic. We can put aromas in mirum and give it a new, consumer experience that maybe surprises them. So we work with customers on what is their performance criteria and then engineer a material to suit.
Okay. There's a quick question I think we can answer quickly. What database do you think is best to follow, I guess, for LCA? So the common one is the Higgs index, and I guess the creep model, I guess, is the two things to answer that pretty quickly. I'm going to go to the bottom here. I love the materials you're working on. As someone that makes products from these kinds of materials, what are the major roadblocks to production on a scale that compares to cheap synthetics, major roadblocks to economic recircular reuse? I think this is a quick one we got 4 minutes. So Tom, maybe you should answer this one because you're on the brand side. The roadblocks. We've spoken about them directly. I guess cost is a major one, but talk maybe a little bit about the challenges in production and changing over tooling and production processes relevant to new material.
Yeah, so I think that there's a few different areas, just in terms, I don't know if this is a short answered question, but it's in the production of the material itself, like, whereas, we're looking, what Alex mentioned in terms of where they're at in a commercialization phase, like when we bring on a supplier, we need to know that they can provide us a full data set about all the physical and chemical properties of that material, that it's fully commercialized, and we can order as much of it within our normal time frame of ordering materials, that it doesn't disrupt our supply chain. And I think that's probably the number one reason for slow adoption. There's price, and then to me it's also like supply chain interruption. And the bigger, we're a smaller company relatively, so we're more nimble. A bigger company like a Nike or an Adidas or something like that, they have, within the footwear realm, they have even bigger challenges to that. And you'll get one-off projects like you see from Adidas and Allbirds recently had one that came out, or you see the 4D kind of shoe that Adi does and that kind of stuff, but or the Space Hippie from Nike, but those are kind of those are pet projects. That's not their bread and butter. They're selling lots of running shoes that are made out of synthetic materials, all plastic. You know what I mean? And so I think that that's probably the biggest challenge is the supply chain aspect of it. And it's also the willingness, we want to work with companies that are building their technology so we can build with them. And that's why, like your company, Jason, and Alex, and Luke, I'm just meeting now, but I find his business also very interesting too. We want to be able to, as we grow, we want to be able to grow with the companies that we're working with on materials development. But I think that really it's like, to me, it's supply chain interruption and price are probably the two big ones as to why materials aren't adopted right away, or there's that's a challenge that is posed.
And it's interesting because when you do talk to the bigger guys, it immediately goes to price and supply chain management. So I just like to finish off with one statement before we're kicked off here. But, I think one of the things that we have to understand about plants is not only, as Luke talked about, scalability, but it's regional diversity, right? And everybody can grow their own feedstock. We're not monopolized by one feedstock, with certain territories having a monopoly or a controlling stake over what you're doing and how you're wearing it. And I think this plays into places like Africa, South America, India, where they're not nascent, maybe Southern Africa, not as oil abundant as say Northern Africa, and all these regional conflicts that were created by this raw material. So plants it's a growing innovation. There's a lot you can do with it. You can extract stuff from it. You can use it as is. You can grow it for a specific purpose, and you can always optimize agriculture as we grow and look at this. So I think when people say, I don't want to use corn today because it uses too much water. Well, water is actually in the LCA, and also it's an abundant regenerative feedstock that is grown locally. So I think we have to start taking things in incremental steps and looking at this as opportunities to grow this business, make these products ubiquitous across various industries, and always ensure that we're reducing our carbon, not putting toxic stuff in. We can look at circularity, biodegradability, recycling, upcycling, and all that stuff. But I think it's important that we look at not killing the planet anymore with our materials that we wear just for the sake of wearing them, right? So thank you
said.
for our panel, and appreciate Alex, Luke, and Tom. I think it was a good panel today, and thank you for Fashion Takes Action for having us involved. Thank you.
Yeah, well, thank you. Thank you for your generous support, as well to our other sponsors this month, Lensing Fibers, DuPont Sorona, and to South Pole, who is offsetting our Wear series, because there is a footprint to these virtual workshops. Our June Wear series takes place on June 23rd. Registration's already open. It's going to be a little different for those of you who've been regularly attending our series since September. Next month, our theme is innovation for a sustainable fashion future. And we've had so many entrepreneurs apply for one of 6 spots in our demo day. So we will be announcing those startups very soon. But in the meantime, you can head on over to the Wear website and get yourself a spot. So thank you again to everybody. Thanks for the participants, and have yourselves a wonderful day.
Thank you.
Thank you, everybody.